I was dreaming of.
That's good. I know that you're gonna do it one day. Anyway,
One day, Professor.
yes, 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 yes. Just promise me you will do it. Okay.
I'm ready.
So, what's going on with the project so far for everybody here? What's happening with the project? Project. No news. Are we gonna move with no news? Good news.
I'm just curious, for your UART and your FIFO,
Yes,
is
sir.
it when you input like let's say you input H, you got 63, or you got a number corresponding to its ASIC value.
Yes.
Uh, for some ASIC values that are smaller, like let's say 0 through F, or
You
from
mean
0,
the ASCII one?
yeah,
Okay.
they translate into its corresponding bit. So like 0 is 0, or sorry, 1 is like 2 bits,
Hmm.
or 1 is 1 bit, 2 is 2 bits, and then something like F is 4 bits.
Hmm.
And does that play a role in like your FIFO because it takes in, you
No,
know,
no, no. Normally, you already have. Normally, you send 8-bit, right, from the UART. Do you agree?
yeah,
So your C driver should be very easy, right? You're just sending a character, right? You need to,
yeah,
that part, I didn't go through because I believe that all of you know C, right? Did you guys take a course from C, right?
I did, yeah.
Yeah, the C for engineers course. Yes.
Yes, 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 yes. So end of the day, it's C. There is a ton of examples for how to write a program taking data from C perspective. I can find you some. I think I have some, but they're Linux operated, so you have to use the GCC. How many of you heard about this GCC compiler? Compiler. So in Linux, when you write a code, right? You don't just go into Visual Studio and then push buttons and stuff like that. Actually, it's a command environment. So you write GCC space, and then the execution parsed in this specific file as an O, and then what type of flags with GCC you have to study this. That's a terminal thing, yes. And then from there you will go into the what is the file you would like to execute, which is basically the gonna be .c extension. Then after you run this code, you will generate the executable, and the executable you will be working. Yes, something like that. Correct. Then you also have a room for doing something called makefile. So you don't need to do it by your hand every time in the terminal or the console, whatever you call. But what you can do, you can actually do something. It's called makefile. You will spell out what will happen if you spell out the name of this makefile. Let's say the makefile is called make. Then if I write make in the terminal, it will do all of these hidden lines one by one and execute it in front of you. It's more command environment than what's called than Windows. And then there is two things you can use in Linux. One is called Bash, and one is called Shell. And that's Bash, and the other Shell. Frankly speaking, to be honest, you need to learn Linux. My question here: how many of you are in favor to work for the normal industry? I believe most of you, right? And normal industry, they use Linux operating system. But maybe some of the branches in the defense contractor, like Northrop Grumman, some of them they work with Windows because Windows is a baby of Microsoft, and the Microsoft you can consider it like the government company. So most of the governments, most of the federal and state funds for in terms of IT, they go to the buying Microsoft products. But if you like to work and exceed the limitation of Windows, by the way, everybody know Windows is limited, right? Limited by what? I give you an example. Let's say that you didn't run the updates of Windows. Something wrong happened while the Windows update itself. Guess what? Maybe the internet driver will be, the Ethernet driver will disappear. Then you're gonna investigate the whole entire day, figuring out what's going on, right? Then one of the program disappeared or is not working anymore, and most likely 90% of these problems coming from updating the Windows itself. But Linux is not like that. I'm working these days with Red Hat Enterprise of creating new series of courses for embedded systems using Red Hat Enterprise. So if I have the material with me, I will share it with you guys. I don't have any problem. But what is open source Linux you can use as a student? Even I'm using by myself. I have in the other machine in front of me here, I have Ubuntu. So Ubuntu, Fedora, CentOS. CentOS Linux is completely close to the version of the Red Hat. So if you don't have the money, because Red Hat Enterprise, you have to pay money. So if you don't have the money for paying the license for Red Hat, people say go to CentOS, because CentOS is almost like Red Hat, but removing the extra support of the help and support part. That makes sense? There is also Mint. There is a bunch of open source Linux, which is very well known, and companies like Xilinx use. When I was working for Atmel, which is a microchip company now, we're using Red Hat Enterprise. It's more stable. There is a customer support, stuff like that. Company has the money, so they pay for it. Any question about this part? Let me find you the UART example. Let me find it. And if I find it, I will open it for you in front of you. UART.c. I have somewhere here, I think it's in my PC. 1 second. Here. So let me open in front of you the share the screen. Everybody can see my UART file? Hello?
Yeah.
So here, I can just come here and say open. I don't know if it will need editor, it will be opened by Windows. Let's see. My computer is almost dying. I don't have that much space left because of all the experiments I made. I don't know what's going on, so what we can do is just go like this. Yeah, it doesn't know how to open it. It's open. Look, that's basically what you can do. It's a bunch, it's opened by a wrong, Okay, everybody can see what I'm saying? Hello? Here, everybody know while we are working with the C environment, we have to put a lot of what the libraries, right? It's a header thing, right? So you have the STDI, that means you're gonna communicate with IO functions. You're gonna communicate with some library functions, and you would like to communicate with ASCII, as you said. So you need a string functions, something related to the terminals, and something related to the unsigned and unsigned data format, right? Then if you look to it, you're gonna call a bunch of the subroutines. So this is like a subroutine you are calling, right? And from there, because we are accessing the FTDI chip. So you know what is FTDI, right? How many of you heard about this FTDI? Hello. Okay, FTDI is this guy. Let me see. This is the FTDI. This basically is giving you the analog part of the analog part of the UART, right? So you have a software interface with the FTDI, and you have the hardware interface. You don't see the code. Interesting. Let me see what's going on here. I share. Can you see now the code?
Yeah.
Okay. So what I said again, normally in C, you have to include all of the possible libraries you're gonna use in C, right? Like arrow, all of these things. This specific one is for the low-level I/O of the driver. Like how can you get into the driver itself? That's actually people who work with stuff like that, they call them firmware engineer. And most likely it's a heavy demanded job. Okay, it's people actually hire a lot of people for this, and they pay, the salary is not that big, but the salary is like from 90 to 140 or something, 150 or something like that. Anyway, so I'm not gonna go and see. I believe all of you know C. So basically, you have here some functions, subroutines, and then you will make another subroutines, and then you will just call it in the skeleton of the main functions, and then you will be able to access it, right? So this function, for instance, is helping you to communicate with the interface. So when you communicate with interface, which COM thing that you're gonna use? This code is written for the Linux. It's not written for what? It's not written for Windows. Why? Because the function we have here is called TTY. Normally, the function for Windows is gonna be COM, COM. So COM1, COM3. Yes, it's Qt, yes. Anyway, I have a lot of stuff, I have Qt and I have a bunch of editors. Anyway, then what exactly you need to do here, you will just need to say scan all different type of USBs connected, and then automatically it will figure out which one you're already communicating with based on the baud rate and all of these things. Then it's gonna put you a bunch of flags, so you have to look to the software side of the UART, and it's basically open source everywhere. You can find it even in GitHub. Then you will start communicating here in the main. So in the main, say that open the specific port, and then check whether that it will communicate with you or not. If not, send me a message say that something is wrong, because one is basically I'm true. That means I open it. Then I will set up my baud rate. So B here, it's one of the attributes for the whole entire what's called UART. So be sure that when you have the UART in the hardware in the Verilog, say 9600 for instance, you have to go in the software say 9600. So that means you are synchronized, right? So the rate here and rate there will be the same. If you don't put the rate in the software and hardware the same, then missynchronization will happen. You will not be able to see the device. Okay. Then you will have a bunch of read and write functions. And those read and write function coming actually internally from this interface we call. Sorry, this interface I just closed it. Okay. So here, what I'm saying, write value. So I'm telling the command in the software, write 13 into the direction of the board. Then the board will write it, and then you will move forward. Then I'm asking to read back, like loop back, and give me a display. Read anything coming from the board. Like you already have the keys, you push buttons, and the TX, which is RX side, it will be pushing something in front of the screen and so on. So this is something you need to investigate. It's not really hard. If you want, I can send you this code as a reference. So you guys like me to put this code as a reference on the Blackboard? Okay.
Yes, please.
Yes, I'm gonna do this. That's no problem. Okay, so that's the thing. For today we're talking about two things we need to discuss, right? The PWM and what is the other one? The VGA, right? That was our deal. So Let me close this. Excuse me. And let me create a project. Nobody can see my Vivado, right? You guys
No,
can you
not,
see my
not
Vivado?
yet.
Okay, so I'm gonna open the door. Let's call it VGA work. Okay, and then out here, I'm gonna share it now. Everybody can see it now.
Yes.
XC7A100 TS, and then XC700 CS. Do you guys remember what was it? XC7A100. Scheiße, what's going on here? XC700. What was the number? I forgot. Let me check.
You could also pick the board.
Yeah, but I have an old Vivado because my computer is very old. XCC7A100 TC. Yes, I found it. Okay. And then I say finish here, right? Sounds good. Vivado went to the other side, so I'm gonna bring it to everybody. See Vivado again, right?
Yes.
Take this aside, and I need my numbers here, so I'm not gonna waste your time. 1 second. Okay, we're gonna build the driver first, and we said the driver is just a bunch of counters, right, with some requirements. And let's see how can we make it. It's not really hard. So come here and say that create a design, and then just call it here VGA driver. So we are building the driver which will be poking the analog signals coming from the IBM communication protocol for the VGA. Okay, and we need to sort what type of signals we're gonna have. So basically, we're gonna have a clock. Everybody agree? And then we have a we have a reset, or let's call it clear. And then we have HSync, and we need VSync. And we know that VSync and HSync, these two guys are what? The VSync and HSync are those two guys should be outputting coming from the board, hooking the analog side of the VGA on the screen, right? So that's why they're going to be out from us in there. Then we need two things that are going to be an extra coming from the. How can we figure out a counter with a resolution of the blue and green and red that we mentioned before? So we're going to say it here, it's going to be HC, and we're going to say also they're going to be HC and VC. Okay. Then we need another signal. If you remember from the VGA, if you still remember that, right? There was a part that's going to be dark, part that's going to be dark, and we are waiting for signal to be from high to go low, right? And then there is a place in the middle, and this place in the middle we call it display zone, right? Which is the zone that we can receive any pixel and it will be recognized by human visual system, right? So we need a kind of a fancy signal, and we're going to say video on. And that's going to be an output. This also going to be an output. This is going to be an output. What is the resolution for this? Normal resolution is going to be 333, right? So normally when I'm going to make it, I'm going to make it 333. So RGB. So going to be 9. So I'm going to make it 10. So going to be 9 down 2. So going to be here 9. 9. And that's it. Okay. So then I can move forward with my code and see what else I'm gonna do. Takes time, I'm sorry about that. So we'll just go here and say VGA. So here is my interface, as everybody knows. Sounds good? Okay, so now we're gonna start think about are we gonna make this code kind of parameterized or not? Do you guys agree? We should make something more parameters, right? So if you guys remember, what is the best way for you to put here parameters? If somebody remind me, we put the parameters here or not? So we have to make it like this.
I believe it's after the module name.
Maybe we can make it a parameter. Just let me find a good name for you. It's hpixel, pixel, and positive, and equal 800. Why there's an error? I forgot where is my parameters.
Yeah, I believe it's after the module name, the parameter goes. So it looks exactly like that, just after the module name.
Yeah, I have done it before with before the module name. Just give me 1 second. So I have a code written before with parameters. So where is it? You know, these days I have a ton of deadlines. It's like affecting on my work. 1 second. No, that's a VM. Wait 1 second. Why somebody, somebody can correct me? That would be interesting. See, so parameter in like, because I wrote a project yesterday in VHDL to take some time for me. Okay, so this is something coming from different language. So what is the problem?
Doesn't the parameter come after the VGA driver name?
Okay, so that's what you're saying. So I should take it like this out, right? Okay, like this.
Right before the parentheses.
It can go here also, but it will not be fully parameterized as. Yes, you're right. That's completely correct. So I can just make it like this. That's what you meant, right?
Yeah.
You're right. The other way I made is still work. It's applicable. The one behind, after this, but it will not be as completely parameters or not. Anyway, so now, back to the code. So we have here 800. That means, it's gonna be 800 the whole entire thing. Okay. And then, we need another parameter, which is going to be parameter. And this parameter is going to be called V lines. How many lines in a vertical is going to be used? And that's going to be 512. These numbers I didn't invent. This number coming from the thing that I shared with you before. Do you guys remember this? And there is something that's called horizontal back force, and there's something that's called horizontal front force, right? So they're going to be horizontal back force, and they're going to be also parameters. Horizontal back force, and they're going to be equal to the 128 plus 16. It will be what? It will be 128 plus 16. And I will tell you a reason for putting it as it is like that. Then, parameter gonna be the front HFP of this operation, and they're gonna be HFP. It should be 128 plus the 16th, and then you're gonna go to hold the entire horizontal. That's gonna be 640. So 16 plus 640. Let's see what is the error I have now. Why there is an error?
I think there's supposed to be commas and not semicolons.
Oh my gosh. Okay, so you guys are completely great. See, you guys now are way better than me, which I like, you know? Ah, scheiße. Anyway, I'm gonna stop this. I would like to share with you something interesting, you know? I'm attending this conference, which is in Scotland. I have a paper there about quantum crypto processor, something, you know, I built. So, you know, if you guys would like me to send you the proceeding, it has a fantastic papers in terms of circuits and computation. I can give you the paper that will help you also to build a picture about what's going on. Okay. Here now we make the horizontal. Now we're gonna make the vertical. So gonna be also parameter vertical back porch, and that will be vertical back porch. It's gonna be 29 plus 2. So gonna be here 29 plus 2. Let's be more. And this will be this. Okay. Then we need the front, right? So parameter front porch, and that will be the 2 plus 29. Yes, because you know you go like this. So 29 plus the whole entire width is going to be 480. And that's it. So we have each pixel, we have V lines, and we have horizontal back porch. We have vertical horizontal front porch, and we have vertical back porch, and we have front back porch as well. We are ready. We can build anything we want. Okay. So now what we can do, we need to go ahead and create the process of the whole entire thing. So what I'm gonna do, I'm gonna make some internal registers as we do before, you know, is always blocked as a procedure block, right? And everything gonna be clocked because we are working in a counter behavior. I need to see something going high like this, and I'm gonna be covering the whole entire display time in a horizontal. Then I will go down with front and back porch, and then I will go up again in a certain amount. Then I will keep doing the same thing over and over and over until I will cover the whole horizontal. Then I will start taking the second vertical and do this again horizontal many times. So what I'm gonna do, I'm gonna make something that's called rig, and I will call it VC enable, and they're gonna be just one bit, single. Then you know I'm gonna also go ahead and say rig 9 to 0, and they're gonna be the HC, and I'm gonna call it rig, and another rig, and it's gonna be 9 to 0, and they're gonna be VC rig. You guys know what I'm doing, right? I would like to make it like a unique entity. Then I will tie this VC, HC reg, and VC reg to the HC and VC I have written here. Okay. And of course, you know, those guys are registers. So those guys has to be defined as a register, by the way. So those guys are registers. And they're going to be also registers. Okay. This also going to be reg for now. And I might actually turn it to be what wire end of the work. The first process is a counter for the horizontal. So I'm going to write here a command, say counter for horizontal synchronization signal in the analog domain of the screen. Okay, then I'm gonna give it a name and I call it CHSS, something like that. Maybe I can just make it here in the comments thing, and I say CHSS, and then I will start building the always block at pause edge of the clock or pause edge of edge of the clear begin end. Okay, so I build this, and you know sorry, and then you know I call it CHSS. So far so good. If clear equal If clear is high, then I say here begin end. Don't forget, if statement itself is good to be working as a one line without begin and end. But if you already have a bunch of lines will be affected by this if statement as a control statement, you have to put it between begin and end. I have noticed while I'm grading, some of you guys forgot about it. It's important. It's critical. So you say hreg as a counter. I want it to be equal 0. So that's going to be 9 d 0. Okay. Then also I say v's enable is going to be also a 0. So going to be 1b0. Then I'm done with this. I'm done because I'm just building a counter. Okay. Then I'll go here and say else begin end. What will be else? The else it will be if, look, HC reg at the registers equal what? Equal the H pixel minus 1. So did you see what I'm doing? I'm starting using my parameters. H pixel, the horizontal of the pixels is going to be on, right? So what I'm expecting there, I'm expecting multiple things to happen. So I will say begin, end. And there I can come and say, I will expect HC reg to reach the boundary of the pixel area. So that will open the door for me to say going to be 9d0. Also, in that case, I can elevate a flag, say that, you know what, I reached the boundary. So I'm going to make it 1 here. Everybody's following me, right? Hello?
Yeah.
Okay. So is it clear so far what I'm saying?
Yeah.
Yeah.
So now else, this else is not related to the else up. See, that's why you have to be organized, right? And that's one of the things that, one of the editors will help you. Do you know that that's one of the things I would like to share with you today also? Do you know that I can write a code outside Vivado and then I call Vivado for synthesis? It doesn't need to be using the editor of Vivado. Everybody know the story or you don't know? So you are not constrained by using the thing that came with Vivado. This is the editor of Vivado. You don't need to use it. You can actually use any editor, Vim, Emacs, whatever, Finish or Notepad++ or something like that. Anyway, back to this. So what is my else will be? If I don't reach the boundary, that means I'm incrementing, right? So it's gonna be hreg equal HC reg plus 1. So I'm just making a counter in a behavior model. And in this case, I'm not expecting that I reach the boundary. So I'm saying gonna be B and 0. So by this way, this piece of code in a always procedure is covering the idea of moving toward the horizontal thing. So now what will be the most important part to do is gonna be the generating the pulse. Because if you remember, the pulse, I don't know if you guys remember this, but I can open it in front of you again. So the VGA timing. Let me share with you the signal I'm talking about. So image. Can you see this? Everybody can see my screen? Hello?
Yep.
So, now I need to generate this. Okay, I just made a count up to count. I just need to generate the sync and V of the signal, which is on high for how many times, including, of course, that's play plus the front Porsche. And then, the sync pulse, it will be going down for an amount of time. Then it will be forward by the back Porsche. Then they're going to be repeated as much as you can, as the resolution is already made in front of you. So in this case, I would just put here in a comment and say that, I'm generating H synchronization pulse low when HC reg is 0 to 127 dimension coming from the timing of the analog side of the driver located in the screen. So how I'm gonna do this? It's also another clock, another counter under process. So in that case, I'm gonna say it's an always block with positive edge, edge of the clock or pos edge of the clear, and then begin N. And this process, I'm actually refer to it to be CS, not GHSS, because you know I'm actually generating. So you're gonna be I'm sorry, clear begin. And in this case, I need begin and end? I don't, because you know generally I'm just like synchronizing the thing itself. So we're gonna be here 9D0. Okay, then somebody would say, Professor, do we need begin and end? I don't think you need it, but I'm a person like to use it all the time because let's see everything under each other. So gonna be here else, and this else means that the positive edge of the clock will be involved in this, and I would say F HC reg is less than 128. So that means I'm talking about the value to be 0 to 127, as I said in the comments. And if this happened, what will be my process? It will be H sync equal 9D0. That means I'm outside the range, so I'm not expecting anything to happen for this. So gonna be H sync equal 1, which is gonna be 1B1. So this little itty bitty tiny things generated that H sync when it will go high like this, and then it's gonna go down for amount of time, which is a pulse, and then go up again and go high, and then return it back to be high for some certain amount of time, and it's then gonna go down and so on. We have to go ahead now and do the vertical. And we mentioned that the horizontal is driving the vertical, not the vertical is driving the horizontal. So that means horizontal will be like boom, 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 going from up to the bottom. Then you will increment one vertical. Then you will do again boom, boom, boom in a vertical. Then you will increment the vertical and so on. That's actually the way how it works. And this is how the test bench should be written. The test bench should be looking to this specific behavior. So in that case, I'm going to go ahead and say I'm going to make another always block, but they're going to be for the counter for the vertical sync signal. Same thing as we did up for this guy. So what we can do, we can actually do a mess, and we clear it up by taking this copy paste, put it here. It will look really bad, but in this case I can just make it CVS, and then instead HC is gonna be what, VC, and this is not there anymore. Some changes I'm gonna make. So any HC in front of you gonna be what, VC. Any H pixel is gonna be V pixels, and all of the things gonna be, instead of this is gonna be lines. And I'm gonna read it once I fix it. So it's gonna be here VC and VC. Let's go through it fast. So if the clear happen, the counter for the verticals will be what's cleared up as an initial state, and then the V's enable, the one reach the end of the horizontal is actually the one will go ahead and say I'm done. So I have to do this multiple times because horizontal. I'm sorry, I'm actually going and going like this. Horizontal is like this. I'm sorry. So when I reach this button, I increase the vertical. So in that case, I need to rewrite this in a different way. So it's L. So you will go ahead and say, you know what, let me rewrite it again. Okay. So and then we'll go here, and then say VF V enable, the one is telling me as a guidance if something happened or not. If then enable is equal 1, then so that means begin, and F VC reg is equal V lines minus 1. And I think that should be equal because that's one of the things we'll learn as an operator side. What will be the consequence of this? It's going to be VC reg is equal 9D0. Okay. Then if not, I'm actually incrementing my VC reg by 1. So do you see what I'm doing? Everybody clear? Understand what I'm doing? Excuse me.
Yeah.
Okay. Now, we're gonna go into the generating the vsync pulse as we did with the other one, right? So gonna be here generating the vsync pulse, and we will be sure that vertical sync pulse is low when VC is 0 to 1 in this case, because you already have 2 for the from Porsche, if you guys remember from the parameters and the above. So in that case, I'm gonna make also an always block, always at positive edge of the clock or positive edge of the clear, and then begin. And I'm gonna give it a name with G, so gonna be G sync V. And there I would say F clear is high. I will be sure my V sync is gonna be cleared up. No, the V sync is gonna be no, V sync is 1 bit, right? So gonna be 1. I'm sorry. And then else, that means I'm going into the clock itself. So if it's clock happening, so I have to say F VC reg is less than 2. That means between 0 1, something will happen. So pretty much I need to make this begin and end. And then I push this one line. Why this is giving me an error? V sync. Yeah, right? Okay, I'm sorry. That was my mistake. It's my bad. Anyway, so in that case, it's going to be V sync is equal 1B0, else V sync in this case will be out of it's going to be 1. So going to be 1. So far, so good. Now we need to enable the video, and we'll be done for the driver. So we are just generating the 2 signals, so that the screen will start acting with us, right? So in that case, I would just say this is the last process, which is opening the door for the display itself for making manipulations. So going to be enabling video out when it is within the process. Okay, so in that case, it's going to be always at positive edge of the clock or positive edge of the clear begin, and I will call this process ENV because I enabled the process, and I will go here into it. Then if clear happen, then this is the video on, because I'm not actually running anything, right? So gonna be 1B 0. Then I would say else, and from else I will be into a condition process here. So what is the condition process will be? If I'm looking for the boundaries of the vertical and horizontal. So in there I would say if HC reg is less than HFP as a one of P's, and what? HC reg greater than HPB. Are we done? Nope. I'm going to show you some more because, we are now just covering the horizontal process. So we're going to also put the vertical into the process. If all of these conditions happen, so I'm actually video is on. If not, the video will be off. Okay. So, I made this horizontal part. So I would say, and, sorry about that. So, and, and what? And VC reg is less than VFP, okay? And also VC reg is greater than V back push. So back push. Then if all of this condition, all of these boundaries happen, I'm literally saying that, this is the area the video will be seen. Else, the video will not be happening because I will be in the dark side of the screen. So, I don't know why there's an error. Let me see. I didn't get it. Huh? I think there's a stupid error. Oh, I know. Begin. See, I made the mistake, which is causing the whole entire problem. Didn't get it. You know what? Let's take this out. Okay. Let me see what it is. Huh. Still I have an error. Why I have an error?
Professor, you put it as always to instead of always at.
Yeah. Yeah. Good catch. So that means you guys are actually alert what's going on. Thank you. I appreciate it, by the way. So who actually corrected me, Anish, right? Who corrected me? I would like to thank him. Who? Was Anish or who? Eduardo?
Yeah, it was me. Niche.
Thank you, Anish. I appreciate it. Okay, so now, guess what? Do we have any error? Do we have anything? Pretty much what we have here is called VGA driver. Using what? Verilog language. So far, so good? We didn't do anything wrong. We're just like, communicating with the whole entire thing. Are we done? We are not completely done. Why? Because, we have to come into a conclusion saying that assign VC equal VC reg. Assign HC equal HC. But I'm sure there's an error. Why? Because I made the VC and HC what? Huh? Made them reg. They have to be one. Yeah. Oh, sorry. That's the data concurrent. Yes. Okay, so now everything is ready for building a wrapper around the driver. Anything you would like to do, you would like to make emoji moving from here to there, you would like to do some crazy stuff, you can do it. But you know, this will be the door for you to communicate and make the screen pop out light and talk to you. That makes sense?
Yes.
Okay. We need to see something, right? I mean, this is what we learn in this course. You know, we do something, we see something, right? So because I don't remember what was my XDC file, so I'm just going into the GitHub and get the XDC. So I'm gonna say, what XDC? It's called XDC, right? Nexus for XDC. So I, this is my own traditional way. You know, my screen is getting huge. I don't know why. Copy, and then I go here and add source, create constraints, and then create the constraints, and we'll just call it video. Let's call it VGA. Finish. And then we can just go here and say, here is our clock. But I have a news for you. This clock is not the 100. It's not the 100 mega clock. We just built a driver. It's not the 100 mega. It has to be something. But we're gonna talk about it when we build the wrapper in the top. So we have a clock. We have to have a reset somewhere. Don't worry about it. I just need to see where is the VGA, right? Those guys will be like this one, 2, 3, 4. And that will be the VC HSync, and that will be the VSync. VSync. Sounds good? We are not done. We are not done. We're gonna now build up the extra wrapper around the process. So let me build it for you. Okay, so I'm gonna build a new module, and it's called, I want the stripes on the screen to see it moving or something, just making something, to be noticed while we are playing with the keys. So I'm gonna say here add source, and then I say design, and then I will just say here, stripes, or VGA stripe or strips or whatever. Then what will be the block itself? It's gonna be clock, it's gonna be reset, it's gonna be BBR 222, because red, green, blue. I'm not gonna make the whole entire resolution. So it's gonna be here 1 BBRG, and then another one BBRGB. What did I make wrong? RGB. And I want it to be, I'm not gonna take the whole entire resolution, so I'm just gonna make it 1, 1, 1. That means I'm gonna have 4 combination. Okay. Then I need the video on, because that will be turning the whole thing on, and that will be input. And then I need the HC and VC that we got from the block of the VGA driver, right? Those will be input to here, and their output there, right? So gonna be here HC, and that will be VC, and this will be input as it is, and it's gonna be here 9 as before, so 9, and then gonna be also 9. 9. Okay, guys. So HC and VC. Then I want to have colors. So what is my color as? It's gonna be the red and green and blue, right? So it's gonna be red, green, green, RGB, green, and blue, blue. And those will be the 3 resolutions, 3 bits, 3 bits, 4 bits. So gonna be 3, 3, 3. So gonna be 12. So 3, 3, 3. Okay. So that's gonna be our box, which will be connected to the driver later on in the top file, and that will actually cause the whole entire thing to see what's called. You will see a bunch of strips or stripes, whatever you call. They're gonna be changing the color and the width of itself, the thickness of it. And we can make infinity number of example after that. So those 3 guys, the B, R, G, B, whatever, those are switches. So I would like to change the color resolution thing based on a bunch of switches on the board, okay? So if you look at it, it's a very small, entire, tiny example, you know? So like here, I can write it in front of you, and it's very interesting to see the result. So let's see what is the in and out. So basically, there's going to be out. There's 3 different colors of output. So it's going to be output, output, output. Okay, and and the rest are input. Now we're going to build our entire module here. So let's think about the module. The module can, by the way, can be a memory, and you store the logo. And then, you know, you will just go ahead and, you know, you can draw a logo. Like, you know, you can say space, 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 make X. And then you will draw the figure. Like, and, you know, literally on here, off here, on here. And then it will, you know, draw in front of you A. Do you remember the same thing with this, with 7 segment display? Huh? Do you remember how the 7 segment display work? You know, you already have pieces, and from there you build a specific encoder for it. And end of the day, it show you how it works. You guys remember that? Huh? Hello?
Yeah.
Same thing. I'm gonna draw it, you know? So I'm gonna here say always at positive edge of the clock, or positive edge of the reset. Begin and end. And that will be, I don't know why it's mad, because, you know, there is an R there. And, you know, from there, I would say, huh? Why, what did I do wrong? Bingo. What is it? Oh yeah, I put it under the end module. Oh my gosh. Okay, anyway, now I'm gonna write if. What is my whole entire idea based on if the videos exist? Do you guys agree? So I'm just waiting for this signal. So it's gonna be video on. If this video on is on, that means 1. Anything else can happen. Do you guys agree or not? Right? So I can actually make a case statement. I can make a literally case statement. But I'm not sure also why this guy is mad, you know, because, you know, this, okay. So I can just go ahead and say if begin end what? I can make a case statement. And this case statement will be for what? For a specific unit for the switches. So maybe some of you can help me. How can I write case statement? How can I write case statement? So what should I write? Hello? Hello? So what should I write here? You know, as a skeleton of case statement. It's gonna be the every single switch, right? So it's gonna be P R is no. What was the syntax for case statement? So
Professor, I think it goes in parentheses.
Yeah, that's actually I wanted to hear from you guys. You guys don't want to help. I'm joking. So what I forgot actually, you have to make it in parentheses. You know, that's fine. You don't need to make it actually. Yeah, I can make it like this actually. Okay, case statement, and I just say in case, I believe in case. What is there? I'm gonna say that it's gonna be all the different combination of the case statements. So gonna be 2D0. Something will happen. 2D1. Something will happen. 2D2. Something will happen. 2D3. Something will happen. Default. Something else will happen. And you know, as you said, they're gonna be consistent. Right? Okay, so what is gonna be in 0, what is gonna be in 1, and all these things, yada thing. So basically what I can say, you know, I'm looking for the R standing for what, guys? R standing for red. And you know, I'm in the clock, so I'm guaranteed that gonna be registered. So I'm gonna be here registered. Here is the register, you know. So I'm gonna say here it's gonna be red, and red in this case would be equal what? So how many of you remember concatenation? How I concatenate stuff? Yeah. You remember how can I concatenate stuff? Oh man. Yeah. So gonna be the VC something. We can make it an array. Yes, you're right. I mean, there is a bunch of stuff. I just need to make a small example, you know. What will be the values? Something, you know. I can make it like this, you know. I can make it's gonna be a manual, but you know, you guys can think about it. You can make any infinity ways of defining it, but you know, I'm trying to make it something simple. So I can say VC, for instance, you know, look, VC 0, okay, VC 0 what? VC 0 0 0. VC 0 VC 0. If I make a mistake, oh, 0 VC 0. So do you see what I did? So what I did, the switch equals 0. So what I'm saying, I would like to repeat the value of the VC, the first bit there, multiple times. You can make anything that, you know, you can invent anything. That's why I'm just making an example for you, but you know, definitely all right. You can make infinity ways of the thing. So, you know, red, let's just stick with this, you know, as just an example, right? We're gonna be here like, you know, 1. Then you know we're gonna make it here red and make it 2 2 2 2 2 2 2. Then you know we're gonna take a copy of this and make it 3 3 3 3. Okay, so by this way I just built a switch deciding what is the intensity of the redness, right? By whatever form I want, right? And I can just come and say here, you know, red will be for the Z, like it's gonna be open, like, you know, hanging, right? I can come into the skeleton because, you know, I'm in the behavior of the behavior modeling. So I'm gonna just go ahead and say that, you know, instead of BBR, we're gonna be BR. What was the other one? G, right? So gonna be G, right? So I can just say go in G, right? So I can come here and say that, you know, gonna be D, and then, you know, this really gonna be green, right? So I just say here green. 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 Then I can make the third one with gonna be what, blue, you know, something, you know. So you guys understand what I'm doing?
Yes.
I'm gonna be blue. And you're gonna be blue.
Actually, Professor, what you mentioned earlier about concatenation,
Yeah.
how exactly do you spell that?
Concatenation?
Yeah.
You mean as an English word or?
Yeah.
I will do it for you now. 1 second.
Concatenation. Thank you, Rohith.
Okay. So what I did now, I just made three different case statements controlled by the variation of combination of switches on the board, and it's helping me to draw the thing based on the video on. That's it. That's basically what I did, you know. And what I can do, I can just come here and say, if reset happened, begin or not begin, you know, I don't need it. Oh yeah, I need it, begin. And from there, I can just come and say red equal for D0, blue equal for D0, green equal for D0. Then I come say here begin, else begin, and then, you know, end of this is gonna be n. I think I missed one n, I believe. Yes. Okay. So we built the brain of the block we're gonna do, and yes, right, it's correct. It's called concatenation. It's correct. This is how it's you spelled it out. So now this is the box. You know, right, or the news. You know, you can make shift. You can actually build a VRAM or block memory, and this block memory will be having the letters. So for instance, you know, Luis, when you talk to me about, you know, the UART thing, one of the tricky things you can do is the following. You can make like a big encoder, and you make you can draw the letters, right? And then, you know, when, you know, you pick data from the FIFO, it will look and say 56. You know, 56 is an A, right? So you will go into a specific location in the memory, and you will pick up the drawing thing, and you will go and you distribute. You will draw it on the what's called on the screen. You know what I'm saying? So gonna be, you are sending something raw, and you will send it through the FIFO. And then when you will pick the data out of the FIFO, you know it's a 56, but you know 56 is have a meaning in a character, and you know from ASCII it means something. So you make another table, say 56 case statement. If it's 56, draw this for him. If it's whatever, you know, draw this for him. You understand what I'm saying? This is one of the easy, I mean, very simple, naive way for doing such a kind of thing. Okay. Now we need to do the most important, interesting part, which is combine this together. So you know, I can turn on here in front of you on the screen something to be running, right? So I'm gonna make the top module. So how this top module will look like, this is basically what we're gonna figure together, right? So, excuse me. So here, I'm gonna make here a top module and I say create design, and I'm gonna call it here top. What is exactly I'm expecting out of top? I'm expecting a lot of stuff, right? I'm expecting clock, I'm expecting a button, and I will call this button as a button, just like a button. I'm just changing names. And I'm expecting anything. I'm expecting switches, for instance. I'm expecting there is a way to make it very clear, actually, to make it tricky. You can change based on the whatever the BTN. You know what? I don't need to complicate it for you. So it's gonna be BB R BB BB green, and then BB blue, and those are inputs. So it's gonna be 1, 2, 3. Don't worry about the switch. I'm gonna exclude it's gonna be here. 1, 1, 1, and here is the sync. We need, of course, it's synchronization, and they're gonna be an output for me. And also I need the sync, and they're gonna be an output also, and there's gonna be a single bit if you guys remember. And we need the red and green and thing, right? So it's gonna be red. We need green, and we need blue, and they're gonna be an output, an output, an output, and they're gonna be, if you guys remember, 333, right? So gonna be 4-bit this presentation. 3. Sounds good. Now we just go ahead and we see what we need. One of the things that I mentioned to you that we also need IP for downsizing the maximum frequency, because the pixel based on the 480, 600, 440 or something like that, the pixel frequency itself is not 100 megahertz, it's 25 something. Do you guys remember that? So we need to build this as well. So what we can do, we can just go an IP catalog and say that I need the thing that was called what's called clock wizard. Yes. And you guys remember this from the beginning of the clock dividers and stuff like that, right? There I can just say is PLL, and then output here. I'm gonna say I'm requesting 25 point something, right? I think based on the documentation. Do you still guys have the documentation with you? The one I sent you? Huh? Hello?
The clocking wizard IP documentation?
No. It's about the VGA, the one I shared with you. Do you remember what was the clock required? I think it was 25 megahertz, but with fraction. Was it 2501 or 25.1? Well, I mean, there is nothing to hurt. I would just do it like this. And let's call it, let's make a name and call it VGA clock. Okay. And we need a reset, we need a clock, we need this, we need this, we need that. I just go ahead and say, okay, create it. Take some time, but you understand what you guys understand what I'm doing now, right? I'm just getting the source of the clock, which is gonna be taking the 100 megahertz into the 25, and then I will connect these pieces together, so everything will be running in 25 megahertz. That makes sense to everybody? Huh? Hello?
Yeah.
Okay, so now we can just go in the top and start calling these pieces until this clock weather thing finished, right? So For instance, this one we need to call, right? So we can just take this copy as we learned before and just go ahead and I'm not sure why this guy is meant here. Oh, because there was a space. And I don't like this to be here as I'm really picky. So we're gonna be here, some errors will come up, which is fine, don't worry. So, we write what VGA is strips, and then, just call it what? Load. Let's make it load. And, then go like this. Dot clock. Dot reset. Dot BB. Dot BB RGB, right? Dot BB dot region dot HC dot VC dot thread dot green dot blue. Okay, Luke.
Actually, Professor, I recall now what you meant about the timing. I believe you searched on Google Images for VGA timing table.
Yes,
That's where you.
And it was 25 something. It was 25.01 or 2.1.
25.175.
Yeah, so it gotta be work because I make it 0.1, so that's fine. Anyway, so clock, we have this called clock still. Let me see. The resets, I'm gonna call it resets here, and I don't need this PTN. I wanted to change it to another name, but that's fine. Then the BB gonna be BB R BB green BB blue, right? Then HC H3, don't worry about those. Gonna be they're gonna be external counter thing, and the red and green and blue gonna be red and green blue. It's gonna be red, green, and blue. Sounds good. Those gonna be something we're gonna create again. So we need the driver here, the VGA driver, right? So the VGA driver, it's here. So I'm gonna take a copy of it and just take go in the top, and from there I can make my mess again. Boom. And then I come here and say, VGA driver, right? Then I put my like this. Then I put here the name is gonna be VGA driver info. Then I will just go like this. So you guys know what I'm doing, right? So there, H pixels. There, V lines. There, of course I have to make a comma. Yeah, come on. V lines, HBB. There, HFB. There, VBB. There, VB. There, what? VFB. So did you see what I did? That makes sense what I'm doing? Everybody understand what I'm doing, right? Why this happened? Because you don't want to change every time the driver. So we're gonna do the same thing. Excuse me. So I will need this guy like this because I don't want to waste time. Just put it here. And those I can just call it what? Top. 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 Okay, so you take the name and top. So now you know you don't need to go every time by your hand and change it, right? If you want in the specific thing inside this top, you know, change the resolution, you can just change the resolution from here. And that's one of the good things about the parameters, right? But if I use the local parameter, would it work, or you know it will not work? What is the difference between the local parameters versus the parameters? Somebody remind me. What was the difference? Hello? Huh?
Was it that the local parameters can't be changed from the outside?
Yes, correct. You are completely right, sir. So do you see what I'm doing now? So boom, we are almost done, and we're gonna see something running in my screen soon. So boom, boom here. Okay, so here gonna be Korok. Actually, it will not be a clock, so I actually need to make something here more fancy. And Scheiße. Not here, not here, here. I'll just go in here and say wire clock 25 megahertz. And that guy will be here. So you guys see what I'm doing? Is it clear? Okay. Now it's sync. It's actually one of the inputs, so we're gonna be this. I'm gonna be sync. Then these two guys are what? Also reg or wires. You can call them wire. HC. You remember what was HC size? It was 0 to 9. Huh? Was the same like this, right? You guys remember or no?
I believe that's correct, yeah.
Those are the output coming from here, right? So they're going to be input where in here. You know, it's really hard to write and talk. You know? Anyway, and then, you know, we need what? Another wire, which is a video on, right? So video on. Video on. That's coming from the driver to control who? To control this guy. So we're done. The only thing that we need to add to the whole entire thing is what? Huh? The clock withers, right? Which is not really hard actually. We take this guy and we take this module, and from there we can add it to the top as well. And then, you know, let's add it here. That's a problem. We just say clock with 0 VGA pix clock gen. And we do like this. Okay, what is this? It's gonna be here dot VGA clock. Clock. Okay, dot reset dot locked dot clock in 1. We take this guy. Bye. We don't need it. So here are gonna be what? Here gonna be normal clock. I'm sorry. Clock. Here we're gonna be the reset. Is gonna be reset, and the locked. We're gonna make a signal and call it locked, and then VGA we're gonna make it name. So we have to make here another wire. It's called lock, and another wire is called VGA clock. Okay, take this guy here, put it here, and put the lock here. So, if you guys remember the thing of the thing of the PLL, right? With it, this locked when it's high, that means whatever coming as an output of clock is basically in a steady state. That means it's actually the desired clock that you already designed. But if the locked went down, that means that thing's not working correct. It's not giving me 25.1 megahertz. So in that case, I need to be smart. Why? I can just make ending to that. So that will be be sure that this block will not be broken if it's running a higher than 25 megahertz. You know what I'm saying, right? So I can say here assign what 25 megahertz to be equal what? VGA clock, VGA clock what? Ended with who? With lock. Now it makes sense? Hello? What I'm saying, it makes sense? Hello? Okay. So if you notice, we don't have any errors. The top module, it has the example of the icon that we're gonna move forward. We have the VGA and we have the clock generator. So everything's perfectly fine. Do you think I'm mature now enough to run the whole entire thing, or there is something is missing? I need to see whether that you guys are remembering the steps. Is everything clear, or still we are missing something? We are missing something, by the way, but I need to hear from you. What exactly we are missing? Tell me. What we are missing? Can you guess what we are missing? Danush, can you tell me what I'm missing? No, it's not the this bench. This bench is something, of course, we are missing, but I'm talking about to make it ready now for this thing to be running. It's a very itty-bitty tiny thing. We didn't connect this to the actual XDC, right? Come on. So yes, we have to connect those guys to the XDC, right? Oh my gosh. So in that case, we have to go and those guys are not exist in XDC, right? Reset is not exist in XDC. It's vsync there. What is this red and green and blue? We didn't even connect it to the XDC, right? So so we go here and say right here is what? Green. There is what? Blue. Okay, now I need what? A reset. So the reset will be a button, right? Let's make it PATNC. Reset. Are we done? Still, we need this PP whatever thing. So maybe what we can do the last 6 switches, because 2, 2, 2, right? So gonna be 1, 1, and that can be the let me see. take the blue. You know, I like the blue to be the last one. I'm mean to the blue, you know. And of course, it's gonna be 0, 1 because you know just 2 bit, right? Then we're gonna do the same thing here with the other one, right? Which is basically gonna be 0, 1, and they're gonna be what's this? Yeah. You're gonna be what, green, and then you know we can go here, and they're gonna be this one, and then make this red. Scheiße. Red. Anything else we're missing? So we already declared the clock. Okay, we made those guys. Yes, we didn't make the reset. Yes, and then you know we put the red and blue and sync. So you know anything else we are missing, guys? I don't think we're missing anything. So I think we can start actually what generate. So far you guys understood, you know what I'm saying. Of course, that test bench is something very important and you have to do, just to make it very clear. But you know. We are running out of time now. So, did you guys learn anything out of today? Huh? I need a cable. Scheiße.
It says synthesis failed, Professor.
Which is good. You know, I like stuff to fail, you know. It doesn't like something here. What it doesn't like here.
I think it's misspelled. The reset.
This one? No. Reset, yes. Oh my gosh. My bad. You know, I didn't sleep yesterday, so I was attending this conference, you know, and I had a presentation, so I didn't sleep. So I apologize for this, you know. Anyway, so here is the cable. We need this, our lovely screen. Yeah. Of this. Is it, chat, is there another mistake? Oh, you're talking about the reset thing, right? Oh, scheiße. Okay, now our screen is hooked and waiting for the moment. It takes time because my lovely computer is very slow. So we use 24 lookup table, 26 flip-flop. Look, you know, we use nothing, right? By the way, the resolution of the HC and VC rig, nobody asked me why is 10-bit. Why you guys didn't ask me this question? I can tell you what is this while you know we are waiting. Basically, you know, these numbers is belong the less than. Is that all this FPGA supports? Yes. But anyway, let me tell you, this number, that's one of the things, but you know, the number that I calculate here, right? Like 128 plus 16 plus 640, right? This number under the umbrella of what? Between 0 to 1024 bits. That's why I make it 0 to 9. Let's say the resolution is higher than that. Then, you know, I have to increase the 0 to 9 to be 0 to 10 or 0 to 11. So these the sizes of the counters HC and VC coming from the timing. Of course, it's smart to make it more bigger and more bigger, especially if you have more resolution to be supported by the VGA. So that makes sense? Super. I see the implementation actually gets increased a little bit, and there is a reason, an explanation for that. The explanation coming out of the routing. So the routing inside the something's called floor plan. Maybe figure decided that the shortest passes it will be better to increase in the size number of registers or number of flip-flop sequential circuit elements, so it will make it better in terms of meeting the timing of the maximum frequency 100 megahertz and the pixel frequency to 25.1 megahertz. There is something it's called manual routing, but I think if I start this, that's gonna take like 2-3 weeks, and we don't have that much time left, right? But if you guys like to hear more about the manual routing, I can tell you, that was a part of my PhD. Okay, it's ready. It's the moment of destroying my screen. Somebody has to pay. I have to pay. Okay, anyway, I just put it now. Oh, I didn't show you this. Have you ever, guys, connected your screen to the board before you flash it? Look. The DigiLens have their own version of demo there. Look, it's funny. You can actually run the... why my camera is being stupid? Anyway, look, it has a ton of fancy stuff. There's accelerometers. Did you see the 3 points? You can move there, and you can move it in, you can move it out. When it go in, I'm moving the board by my hand, by the way. Look, in my board in my hand, it went inside the box is green. I went out as whatever. There is actually here a temperature sensor. If I start scrubbing it, it will go up and so on. But we need to see whether that I will be able to remove this. So gonna be open hardware. My other screen is being stupid now, so I'm very sorry. I need to change it. Look what I did. Everybody can see my screen. Do you see? I'm playing now with the switches, right?
Oh.
Yeah, that was that was actually written in Verilog as well, but and VHDL and system Verilog, Shad. Yeah, but look at this. Is fun, right? I'm playing with the color definitions, right? I can make it for you, even which changes the V strips or stripes you call, and you can make it go like this. Do you remember when this old TV, when the screen when went off, it will just give you a color straps or whatever, and then you will just see them like standing like this, and they will have a sound saying something like that. You can make stuff like this. Let's say that I'm gonna push the button of reset. Look, boom, I reset everything. But then because I reset and I didn't make enable for these counters to give an order to send power to the screen started getting power again after the reset. But look how much time it takes. Look, I push reset and how much time I'm waiting. There was a couple of seconds waiting for that, right? There was a reason for this coming from the diversion and the reduction of the 100 megahertz to 25 megahertz. Somebody will ask me, is it possible to make the pixel running in 100 megahertz? Of course not, because there is something you're gonna learn. It's called analog. What's called co-simulation, which is between analog and the digital environment. What we are doing now, we are giving order in digital to analog screen. And who is actually causing all of this? The H sync and V sync, when they went in the shape that we designed in the 640 to 480 resolutions. So whatever in front of you is 640 times 480 resolutions. If you would like to change the resolutions, we have to play. Everybody see my cursor, right? In the shared screen. We need to play with this number based on the timing. And of course, this will be completely different here, let me show you. Now I actually pushed all of them, all of the color things into 0, and that was my 0. So we said what is what? Let me see. So the blue was in here. Then the green is there, and there is some greenish here. Our red is here, but my screen is old. Here I push too much bluish, with some yellowish, because you are mixing between the stuff. Rohit, you can play more and you make shifting and all of these things, and then we will raise the need for having a processor for making it easier, so less resources will be used. One of the things I need to see how much power the board is consuming. It's it's not giving me too much accurate information about it. My screen is not. What's the shit with the screen? Hello. It seems that I have to change it. No, I'm sorry. It's 0.228. It's nothing. It's almost nothing. 8 is very efficient. And you don't see any red flag from the perspective of the timing. There is a ton of books you can buy from internet, and ton of people wrote this, and then it works. But you will find a lot of red flags and flags telling you that it's not stable. And I read many books before, and all these books are not giving very interesting thing. But this is I made by myself, with some modification and some information from some books and other resources. Anybody have any questions? Interesting.
Will you be posting this code, Professor?
You guys like me to post this code?
I would very much enjoy to see the yes.
Come on, I wrote everything from scratch. Even I didn't sleep. Actually, today I was thinking to put like Mickey Mouse in front of you, but I didn't sleep very well. So that's the whole entire thing. You can even make a screensaver, and that would be even fun. So I just would like you to think about it. If you would like to present this in your project or course project, it's very fun. Why? Because you already have the driver, right? You have the UART. You can just send the thing, and you will build the encoders inside, looking for the value, and from the ASCII you build the table, and you start drawing it like what we did with 7-segment display, and you can actually find a bunch of switches to stretch it on the screen and contract it to make it smaller and bigger and all these things. There is a big room of fancy stuff you can do with this. Okay, so I want to thank you for today. It's already 1:50. It's too much information for you today. I hope that you guys enjoyed the lecture. And I think, we agreed about Wednesday, I'm going to be meeting you. So I will show you the XDC and also PWM as well, right? And after that, we will be done wrapping up. And, you guys will be ready to show me everything about your project and, putting grades and all these things. I posted the grades for the midterm and quiz. I just need to go into my macro I made in the Blackboard to identify the things that I mentioned to you, right? I told you the one who will get a better grade in the quiz 2, his grade will be the quiz 2, not the quiz 1 will be taken away. Same thing for the midterm, right? But if you didn't, unfortunately, didn't good that with the midterm 2, your grade from mid 1 and 2 will be taken into consideration. So I just need to make some changes in the macro, then it will be applied into final grade in the site. Okay, sounds good? Any questions? Any answer? Okay, have a wonderful day. Enjoy your time.
Actually, Professor,
Yes,
I
sir.
believe we agreed to meet, me and my team.
Oh,
you.
yes,
Yes.
the people didn't show me the lab 7, and we have a deal, right? So stay aside. I need to talk to you before I leave, because I have another meeting with my lovely agency, NASA. I have some stuff to finish with them. So, okay, so thank you guys. God bless you. Stay safe and keep in touch. If you have any questions, don't hesitate. Ashley, can you stay in the last, because I need to talk to you about something, because you told me you're gonna think about something. Okay, thank you guys. God bless you. Have a wonderful day. Thank you.